I'm well, Jasmine. How are you doing today?
Doing good. I hear that we're catching you in nap time, so we got to get through this, right?
That's right, unless you want to have a special guest, another special guest appear on the show today.
I would love to see another special guest, but I'll take your word for it that we might get a grumpy version of this special guest.
Yeah.
So,
We're looking good so far. She's still sleeping, but if she comes on, she'll steal the show.
yeah.
So
Yeah,
cool. Well, thanks
awesome,
for
awesome.
having me today. I for one like the Jasmine and Brian show, so I'll be sure to vote that up in the survey. But yeah, let's
Hey, John,
yeah.
how
Hey,
about you
Brian.
introduce yourself, Jonathan? Tell us a little bit about yourself and what you got to do at AWS.
Sure. So I'm Jonathan. I'm a principal PM on the RDS team. I'm going to be talking about today about some wonderful open source stuff that we just launched in Aurora. By night, since we talked about superheroes, I'm actually a contributor to the Postgres project. I'm on the core team, which is responsible for general governance. I'm involved in all different aspects of the project. I'd like to say I'm the least technically qualified of the core team members. I handle like release management, governance, and all the boring technical work.
Yeah, it sounds like superhero work to me.
Yeah.
Always.
Yeah.
Well, very cool. Very cool. So I'm excited, super excited about this release. Can you talk a little bit about what problem does this solve for customers? Because I always kind of think that way. Like in AWS, we have solutions that solve customer problems. So can you talk a little bit about that?
Yeah, wow, where to begin? So I think we've heard the buzz about around generative AI. I mean, it's everywhere. It's a transformational technology. Now, I'm a New Yorker, so naturally I'm skeptical of everything. So if someone's like, "Oh, this is like the best pizza in the world," I'm like, "Yeah, whatever. That can't be true." And of course, when we first heard about these automated chatbots, generative AI, I kind of had like an air of skepticism about it, but diving into it, really diving deep. I mean, it really is transformational, and there's so many different moving pieces to it. So, I mean, the idea with generative AI is that you have like these large, literally called large language models. They've trained on these massive sets of data, and the idea is you can take something like a sentence, a picture, a video, and throw them against this model. I think the technical term is you make a request against the model, and you'll get some kind of answer back to it. And that's how simple it is in a nutshell. But there's so many different moving pieces because you can embed this knowledge in all these different kinds of applications. So that's kind of the high level of it. Because we see everyone working with the chatbots, and you get the answers back to what you're typing in. So how does that translate to building an application? Because you have your own specialized domains and knowledge that you need to encode. Whether no matter what vertical you're in. And this is where we get into the solution today, which is I already have data that I've stored. I've already built up information about my specific domain. How can I leverage this in a generative AI world to create some kind of automated response system or do better searches over the information I currently have? So like we can dive very deep into it in terms of like all the pieces we need to move together. But I want to stop and see if you have any follow up questions to that.
Oh,
Yeah,
yeah,
so
it
I
sounds
think we
super
could
interesting.
Yeah, I'm like we could talk about it all day, right?
Yeah.
Everybody wants to hear about LLMs and foundational models and kind of like what is this and why is everyone saying generative in every other word for the last 6 months? Um, yeah, like I feel like that's the world that we live in these days.
Yes, try saying Gen AI 10 times fast. I did that earlier today and I kept slipping up as I did it.
That's gonna be the new tongue twister that's taught in elementary schools in a few years.
Yeah.
Yeah.
So the area that I've been very focused on personally is a piece of the Gen AI puzzle, which is, see, I already messed it up, the Gen AI puzzle, which is where do you store the information around it? So there's a currency in Gen AI. It's something called a vector. And a vector, it's a fundamental data type. It's a well-studied mathematical structure. It's been around for hundreds of years. Yet it gives computers like such a pain because even though it's essentially a list of numbers, but there's so much that's involved in trying to process this list of numbers. Like you see specialized hardware being built out just to handle it. And so imagine that. Imagine having to like store it in a database and do really fast retrieval of that information. It's hard because in a database itself is kind of like a wonky piece of software because it has to have special properties to be able to make sure your data is stored safely on disk, able to retrieve it quickly. and so on and so forth. So we're basically dealing with two problems there. We're dealing like this wonky data type, and we're dealing with what I like to call a wonky piece of software in a database. And by the way, I love databases. Like there's a reason why I work with them, but it's because they have these special characteristics. So making this like a little bit less abstract, when I was on here a few months ago, I talked about how we were able to apply this technology to Postgres. So Postgres is an open source database. It's been around for over 35 years. Actually, Postgres and I are roughly the same age. If you look up the date, you can figure that out. But it's been, it has a lot of development behind it, and it's been, developed as an open source piece of software for nearly 30 years as well. There's actually no single owner of Postgres. It's a worldwide body of people who are just dedicated to making the piece of software better. And actually, I'm pleased to report Amazon is one of the largest contributors to Postgres now. Like we have a whole team that's just focused on making it better. Now, one of the nice features about Postgres is that it's extensible. So even though the code is open source and you can fork it, and basically create your own database, what you can also do is that you can write these things called extensions, which allow you to build in software and add more functionality to Postgres without having to fork it. So you can install it like today on Aurora and RDS. And this is what pgvector is. So Postgres did support some of these vector operations, but not that many of them. Like there are some certain limitations, and pgvector overcomes those limitations. It adds a vector data type, and it adds a bunch of search and storage features that make it possible to efficiently query and pull out this vector data, as well as be able to store it efficiently and index and search over it very quickly as well. And this is kind of the crux of the demo, because you have all this functionality. Great, we're talking about it in a little less of an abstract way, but what does that actually mean? Like, what can you actually build with it?
Yeah, Jonathan,
Right.
so as you're talking through this, people are still joining us. So we're talking about how Amazon RDS just launched support for pgvector in May, but as of last week, you can now use it with Amazon Aurora.
Yeah. And that's very exciting because you have all the wonderful features from Aurora, and now you can use it to be your vector database as well.
Wow, this is super cool. And one thing that you spoke about that you just resonated with me is you mentioned that it was open source. And I'm a software developer, and I love open source, and I love when products go through that direction. Can you talk a little bit about how this tool is been open source and how you guys are working with that?
Yeah, definitely. So pgvector has been an open source project since 2021. The lead developer of it, Andrew Kane, he actually has been doing research on vectors for many years, and he basically was like, "Look, Postgres lacks a vector data type, particularly for these coming vector workloads. Let me build that out. Let me implement some of the indexes that have been researched on, and let me throw it out there and see." And it's funny, if you go to that app GitHub star history, you can see that it had some stars, some growing adoption, and then GenAI hit, and Brian, it's like unlike anything I've ever seen before. It's like this chart. It's if you're running a startup, it's the chart you want to see. It's like almost like this vertical growth. Like everyone is trying to use it because it helps solve the problem of I have effectively I have this memory. I have either data that I've already stored that I need to turn into vectors, or I'm collecting new data that I'm running against these LLMs. I'm turning into vectors, and I want to be able to store it in my database of choice, which in this case could be Amazon Aurora. And in terms of like what we've been doing, like Amazon, we've been contributing to pgvector, as much as we've been deploying it as well. We're one of the largest contributors to pgvector to date, and there's definitely a lot more work to do. And the key is that pgvector has a developer community, has a developer ethos, and in open source you have to respect that. Having been involved in Postgres many years, I can definitely appreciate that from both sides. And what's great is working with everyone who's interested in pgvector on trying to make it better. So a lot of the recent improvements have been around performance. It's definitely a very big topic when you're dealing with these large sets of vector data. But little things that make it easier to say, like, run a query and not need to worry about tuning it because you're going to be able to get the results back quickly. That's an example of one contribution that we made. And we've been working with other companies, as well as Andrew, for putting in additional features and contributions into pgvector.
Absolutely awesome. Just super awesome. I love it.
Yeah.
Yeah, so tell us a little bit about like who is using this. We mentioned that chart of it's going up. We see how the adoption is going, but who's really using this today?
A lot of people. It's actually amazing to see, whether, it's been talking to, our customers or just talking to people in the open source community. I mean, I can give a couple of examples, off the top of my head. One example I've heard is using pgvector for better semantic search over documents. So talk to a customer. I'll say like there's a certain kind of document that they store. Like their business is being able to search for information within documents and pull out, the relevant information. And they've actually been using, vector type searches for years. I got on a call with them and I'm like, wow, I know nothing talking to you. Like you're educating me and I'm just going to listen and bring this back to the community. And their preferred database of choice is Amazon Aurora. So they've been using some other vector-based solutions to be able to do their document retrieval. But with pgvector being available on Amazon Aurora, they're actually moving that more into RDS and Aurora to be able to do those kinds of searches. And they're able to get those efficient, highly relevant searches to pull out the documents. The other cases I've heard have centered around, surprise, the chatbots. But there's one that I really love is we had a customer move to using pgvector. In this case, it was on RDS. They relaunched their chatbot. They were getting much more relevant results. They put it on Reddit. Reddit users gave like fantastic feedback to it and said how much they love the new experience. And they saw like their query response times get down to like the millisecond range. And again, just like in general, delighted users. So yeah, it's exciting to hear that like people like even like so soon after these launches, like we already have customers happy, delighted, and using it very successfully. And to me, that's great. It's always great to see like something that you work on is making such a positive impact on someone's life, someone's business, and all those wonderful things.
Yeah, that's very exciting. I'm super
Yeah.
excited to see more of this come to life. I'm glad to already see that it's coming to life. But, Jonathan, we do demos here.
All
So,
right. So
We
I'll put
do.
my money
you
where my
ready?
mouth is. I'm ready.
We're ready. I think we've been talking about it. We got the crowd hyped up. I think we're ready to see it.
All right. Let's do it. So let's bring the demo on screen. There it is. That looks like it. So we're going to do 3 demos today, or 2.5. We'll see. We'll see what how we consider all these demos. So the first demo is we're going to build a chatbot. We're going to build a chatbot where we're going to ask questions about about Postgres from information we learned from the Postgres documentation and get back answers. Now I'll warn you. We probably could spend some more time training on this documentation, but we'll see. We'll see how well we do in it. I mean, part of the beauty of this is that you're going to see the app. Like the code is so simple, and here we're going to have a responsive chatbot.
Mhm.
So let's dive in. So we're going to break down the code before we go into the demo because part of the fun of this is seeing like how easy it is to build this. So we're going to build this chatbot. We're using something called Streamlit. Streamlit is an application development framework written in Python that I wish kind of existed back when I was an app developer because wow, it's like so easy to build this out. And we're going to use this framework called LangChain. You may have heard of LangChain. It's certainly making the buzz in the open source world. And what LangChain does is it combines all the key elements you need to basically tie an LLM or your foundational model into your data store and to be able to build out the chat app in general. And I'll pause real quick because there's an important concept in here. And this is like one of the big workloads we're seeing. It's called retrieval augmented generation, or RAG. If you think about it, your LLM is kind of your brain. Like, it's learned like all this knowledge, but it might not know information specific to what you're trying to solve. So an example I'll give is, my significantly better half is an ICU nurse. She has lots of, she knows like, a ton about, medical information. I've learned a little bit about osmosis. So like if I'm the foundational model, it's like, okay, I've read a bit about, medicine. I know a little bit. But quite often I don't know the answer. And in that case, I'm going to go to my better half to be able to get the answer because she has like very specific information about that. That's how RAG works in a nutshell. Is that you have your foundational model is the brain, and then you have an external brain that you're going to go to. So in this case, we're going to interface with a foundational model, which is going to be our brain, and our Amazon Aurora instance with pgvector is going to be our external brain that's going to help augment the information of that foundational model. So how do we do that? Actually, we're going to dive into the code. We're going to see how that all works, and then we're going to see our chatbot like working right in front of us. So the first thing we need to do is that we need to load information in. In this case, what I did was I got a PDF of the Postgres documentation and I uploaded it. And using some Python tooling, it was able to extract the text. Then we have to use LangChain to do something called chunking the text. So a chunk of text is basically where you're trying to get that semantic meaning of what that sentence is. Saying something like, Postgres is an object relational database. That has meaning. Saying that you can partition your data in Postgres and divide it up into its own chunks. And that has a meaning. And LangChain offers ability, there are several different ways to be able to chunk that data. So that way you can send it up to the LLM to get those specific embeddings. So if we see, we scroll up in the code, we see how that works. All this functionality comes from LangChain. It definitely helps you get started, and it has the chunking algorithm in place. You can basically give it some additional instructions in terms of how you chunk it up, but then you have it ready to be able to learn on the data or essentially create the embeddings. So the next step is actually working with the LLM. In this case, we used Hugging Face, and from Hugging Face, what we're able to do is we take all those text chunks, we get the embeddings back, and then we store them in our database. And that's how we create our retrieval augmented generation set, or our RAG data sets. So ultimately, when we're starting to use the chatbot, we're able to pull the information from that. And then the final step is we'll actually have a chat, which what happens is I'll type something into the user input section. We call it the handle user input function, and we get an embedding out of our large language model. We find our most relevant results, then we return that to the user. So let's demo. I'm going to fire up the chat app. It looks like we are ready to go.
Oh, everyone's running, biking, swimming, wheeling. That could get a little wonky, right?
Wonky's the word of the day now. So let's see how this works. So again, I'm going to caution that you're only as good as your data, and you're only as good as your large language model. So what is Postgres? Postgres is an object relational database management system. Cool. So let's see, what is partitioning? So partitioning has been an important technique, particularly for a lot of these things. Okay, we're getting a little confused now. What is a data? There we go. So what is a data partition? So I probably need to work on my data set a little bit better, but it does describe what a data partition is. It's divided into partitions, but we probably want to modify the language a bit. Maybe we try a few other things. How big is a table? Oh, I didn't like that question. What is a Postgres? All right, was a Postgres table? Okay, so we're trying to repeat things a little bit, but the point that I want to take away is, one, we are able to have the embeddings stored within an Amazon Aurora database that we can query at any different time, and two, look how simple this code is. I built a chatbot app with less than 100 lines of code. And I think that really is the main takeaway as we go through this. If we want to see what our database looks like, this is so when we chunk everything up, we basically got about 8,700 of these embeddings. They're all stored within an Aurora database. Let's just take a quick look at what it looks like. So for me, this is I live on the command line, so I feel way more comfortable here. So we see that we have to scroll quite a little bit here. Let me make the screen a little bit larger. So we can see that there's a mix. Okay, this is a little bit hard to read. Hang on. There's a mix of information here. So the most important thing in this is our embedding. And our embedding is basically our mathematical representation of the text. So that's going to be too many results. So here it is. This is our vector. This basically tells us, for whatever text we have associated with it, this is its mathematical representation. And this is what we do to, be able to calculate the similarity between, all the different objects in our chatbot. So again, it's a very simple data type in many ways. It's easy to understand what it is, but there's all sorts of challenges that you have to handle when you're searching over it. So I think it's actually a good time to go to our next demo, unless you have any more questions on this demo. I mean, I think everyone's
just one.
Yeah.
Just one question. This is very cool. This is super exciting. I see that this is an awesome feature that you guys just created. How were customers doing this before this got released? What were the limitations on doing it?
Well, that's the question. So that's a good question. So the key functionality that pgvector adds to Amazon Aurora is the ability to calculate distances between vectors. I think two of the most popular that you see in the machine learning space are the Euclidean distance, which is a line of sight, like how far am I away from, let me try and make it visual. Here's a cat, like how far am I away from the cat? Let me put it on screen. And then the other is cosine distance, which is, it's called angular distance, or like, angle-wise, how far away am I from the cat? So like this is closer than this. So pgvector adds that capability as well as the capability to index over it. So this is a very small data set. It's about 8,700 vectors. You can basically, you don't need an index for that. You can just, run the select statement and search over all of them and get an answer back quickly. But I'll play around with, say, like 1 billion vectors in my Aurora database, and for that you need an index. Actually, you need to like partition and use an index for that. And what these indexes do is that they help speed up the retrieval of getting this information out. Because let's take like 10 million vectors. If I have to like find how close I am to 10 million vectors, that's a lot of calculations you have to do, particularly as the dimensionality of the vectors grows. But if you put an index on it, you can reduce the amount of space you have to search. So maybe you go from searching 10 million vectors to 10,000 vectors. And then, that's a very quick operation. So that's the big thing that you have, with pgvector, and now that's available in Amazon Aurora. Because prior to pgvector, you definitely couldn't do that. In that way, you didn't have that indexing capability.
Wow, excellent.
Yeah. All right, let's go to demo number 2. So this is a Jupyter notebook that's going to show the next demo. Jupyter is incredibly popular in the machine learning world for using it as like a proof of concept. Particularly before you move it into a production application, or data scientists use it to set up their experiments. In this case, we're going to kind of do both. We're going to show how to do something called sentiment analysis using pgvector directly in Amazon Aurora. So sentiment analysis is you're trying to get the feeling of how something is. So for example, we might look at all the comments on the show today and get our viewers' sentiment in terms of how they feel it went. In this case, we get to do a sentiment analysis on fictitious hotel reviews. And the first thing we have to do is install the dependencies, which should already be there, but I'm going to run it just in case. And then, much like we did before with LangChain, so remember, LangChain is the framework that provides the tooling to interact between your large language models and your data store. We use that to connect our effectively our database of hotel reviews we're going to load with the large language model. So I'm going to set that up now. And actually, I'm just going to clean out my database real quick. Oops, wrong window. I'm just going to clean it up real quick because we're going to load a new data set. Remember, don't run truncated in a production system. All right, so now we're going to load a bunch of hotel reviews. 1, 2, 3. So it's going to take a minute to load, or, oh, it's already done. Wow. And then let's just to prove that they loaded, we're going to run this. Okay, so we can see that we have a bunch of hotel reviews. This person said like, great hotel. This person said horrible customer experience. Cool. So we would expect that the first answer is going to have a positive sentiment. The second answer is going to have a negative sentiment. All right. So let's now start learning. Let's get the different embeddings for this data. So this is what this next step does. We're going to take all the all these hotel reviews, upload them to the large language model, and get the vector embedding for them. So now we're going to do a similarity search and try to find positive reviews. And we'd expect reviews like, oh, this hotel was great. I enjoyed staying there, to get a good score. So here we query like, what do some of the positive reviews say? So looking through it, we see like, oh, nice hotel, expensive parking lot, but I guess they got a good deal on it. Great location, great hotel night, good choice. So like we didn't see that like horrible customer service review there. It's all positive sentiment. Mm-hmm. Now, there's different ways we can do this kind of analysis too. Like I said, there's different distance metrics, and depending on your data set, using a cosine distance might give you better results than using a Euclidean distance. This is probably like the try and see methodology based upon your data. So in this case, we're going to switch to using the cosine distance and try to find, what's the most, find me a positive review and give me one answer. So there's a few cool things going on here. So first, this is a natural language query. Like we didn't have to write SQL to do this. We're basically able to take that query, put it into the large language model, and then have it, perform the SQL query against the database that we store. Against the data we stored in Amazon Aurora. And we look at this hotel, like what does a positive review say? Nice hotel, expensive parking lot, got a good deal on my anniversary. That's pretty cool because like we just saw like multiple things happen here that just make it easier to work with data in general. I mean, the first thing is that I was able to use a natural language. I basically just typed a sentence like "give me some positive reviews" and figured out how to do that and be able to get the query and the relevant documents. And we have all those documents already stored in our Amazon Aurora database, so we're able to retrieve that very quickly. And finally, because we were doing sentiment analysis, we were able to find the positive reviews that we want. We actually
Jonathan, do you think that we could make this a little bit bigger? It's a little blurry for some folks.
Oh, that is my fault. All right. Should we do it from the top?
No.
I think we can pick up here.
No, that's perfect. Yeah.
But this part, like I said, I think this part's really cool. And this is one of the things that you weren't able to do until the pgvector launched in Amazon Aurora is, one, this kind of natural language query, and then two, getting the sentiment analysis directly from the vector calculations. But you actually can already do sentiment analysis from Amazon Aurora, and that's the final demo that we're going to do today. If you're still interested in that, do you have any questions on this?
No, I'm super excited. I'm excited about seeing the next one too. So.
All right. So Aurora has, we talked about Postgres extensions before, and Aurora has an extension called Aurora ML. And what Aurora ML does is that it integrates directly with Amazon SageMaker and some of our other machine learning services. So that way you're able to take the data existing in your Aurora database and perform queries directly on it, where you're able to get machine learning insights. And that's really cool because, while working with something like LangChain, in your different applications is nice, and definitely like look at the powerful applications we can give. There's a little bit of an extra hop right now because you might need to have your application and your database, and you have to like route your information between them. But with Aurora ML, you can go directly from your database into SageMaker, be able to get the insight and pull it back all within one query, and do it in a way that's very performant. You do have to set up your IAM roles and permissions to connect your Aurora database to SageMaker. But once that's all set up, it's off to the races. You can do some really cool machine learning insights. So we're going to do the same thing as we did with this experiment with the pgvector, but now we're going to do it with Aurora ML. So what I'm going to do here is first make the display easier to read. I'm just going to show you what my database looks like now. So we have about 10 reviews that we loaded in, and just to show there's nothing up my sleeve, let's just see what they look like. Of course, it's always hard to read a terminal window. So we can see that here. Here's what I do. What I'm first going to do is I'm going to remember the query that I ran. There we go. All right, so we see, these are the reviews that we had before. We can see, they look very similar. It talks about their stay, it has some sort of sentiment. But, we don't have that sentiment stored immediately. But what we can do is we can get that in real time. Let's see, that's a little hard to read. Hang on, let me just adjust the width real quick. Okay. So what we did here is that we took the text from all of these reviews and sent them to, and used Aurora ML to put it directly into Amazon Comprehend to be able to get the sentiment. And we're able to send that back and give not only the sentiment of the text, but a confidence score in terms of how confident we feel about the about the text. So let's take this first one, which I believe had come up in our previous result. says great hotel night, quick business trip, love little touches like gold. I mean, I think we all like gold in our hotel room.
Can I take it home with me?
Exactly. And we like, okay, I mean, we expect this to be a positive review, right? And it says, yeah, positive review, 83% confident. Now let's see, let's go down to this one. Terrible hotel, approximately 2 weeks ago. Yeah, I think we could think that's a negative review. And sure enough, it has negative sentiment, 82% confident. And then there's like, some mixed reviews. Poor value stayed, but nice hotel. Okay, I mean, we can't really tell what that is, right? But it sounds mixed, but we're pretty confident that's mixed. And that's cool because we're able to do that, directly from an SQL query that's fairly easy to write. And all we have to do is just build out that connection between Amazon Aurora and Amazon SageMaker. So I think it's pretty cool. Like it's anything that makes it easier to get insights out of your data. I'm generally a fan of. Even though I've come to the operational side, I'm still an app developer at heart. So anything where I can just like tie things together quickly to get my answer, I'm a huge fan of.
Wow, excellent. This is super exciting. I mean, I can't wait to get my hands on it, just kind of play around with it a little bit. Wow.
So that's a wrap on demos. I'm happy to ask more questions, or we can see if we can further train our chatbot on the Postgres documentation to give back better answers.
Yeah, Jonathan, I'm curious. We're doing some sentiment analysis on hotel reviews, but what are some other use cases we might see?
Well, for sentiment analysis, like any type of review.
Yeah. Could we maybe use it to do some movie reviews? I know we were talking about this backstage.
Yeah, absolutely. I mean, that'd be a great way to, quickly see, let's say, you go to your favorite social media feed, you download what like all your friends are saying, and then, you run sentiment analysis on it to be like, oh, my friends overwhelmingly think it's positive to go to one of the hit movies opening up this weekend, versus the other. And you could figure out things based upon that. Yeah, I mean, there's all sorts of different applications. Like if you need to figure out like what a trend is, or like where people are gravitating towards, this is that type of analysis you can do. And as we showed, there's multiple ways to get there. That we can use pgvector, and we can use those vector queries to find like what are the the types of reviews that are closest together. Or we can use something like Amazon Comprehend and leverage Aurora ML to get to that kind of answer.
Yeah. Awesome. So where can we find more about this work that you're doing, Jonathan? I know you have a blog post that you've recently authored. You are hanging out in some open source communities.
Yeah, man, there's a lot of places. So I think you'll definitely be seeing a lot more blog content coming out, even in addition to what we put on the Amazon databases blog. There's just so much information out there. I think this is where some of these machine learning algorithms could help, like distill down like the most relevant information that I need. But yeah, no, definitely check out our blog. I think there's gonna be some cool things coming out. I know that there's a PG Vector release coming up that I'm very excited for. Like there's gonna be a lot of performance enhancements in it, both for building the indexes and speeding that up, because we want to make sure we can quickly query our data more as quickly as possible, as well as query performance. So getting those insights back even more quickly. But certainly keep checking out the what's new posts that come out. Every time we launch something new, the blogs. There's going to be some webinars. There may even be a reInvent session. So we shall wait and see. I know we were talking about that earlier.
Yeah. That means they got to register for reInvent, which is open now. Registration is open, and then you can see what sessions we have coming up.
Awesome.
Awesome. Well, thank you, Jonathan. Go ahead, Brian.
Oh, I was going to say, Jonathan, you're going to be at the New York Summit, right?
I'm going to be at New York Summit. I mean, so I'm in New York, so I have little excuse. But yeah, no, I'm excited. I know this is going to be a hot topic. I'm looking forward to talking to people about it. But definitely find me at New York Summit, and happy to chat and like hear about what you're building. I mean, the best thing about talking to folks at whether it's like reInvent, New York Summit, is like to hear the awesome things they're building. By the way, that directly informs what we contribute to open source, and how we influence like Postgres and pgvector, as well as all the awesome things we launch for Aurora and RDS.
All right, awesome.
Yeah.
So yeah,
All right.
that's awesome.
Yeah. Thanks, Jonathan. We appreciate having you here. This was a great demo. I think probably my favorite part was seeing this chatbot, but then you got into the sentiment analysis, and I'm like, whoa, this gets better. So
Yeah,
it's lots
thanks,
of fun.
Jasmine.
I'm excited to see what you do next and where we get to on reInvent and all of the new releases.
Yeah, likewise. Well, thanks, Jasmine. Thanks, Brian. Yeah, it's great talking to you. And again, in the survey, I'm definitely upvoting the Jasmine Brian show.
Awesome. Thank you.